of polynomials. We are on page 392. We only had one division of long division. Please choose anything else, and I'll tell you, you can choose from 1 through 32 on this page, anything you want. Is anyone interested in synthetic division? It has limited applicability. Long division works for anything. If you are interested, I'll present it. If you're not interested, we can move on. One method here is good enough.
I'm interested.
Okay, so let's choose any problem, and I'll tell you. Let's practice the long division first, and then I'll show the synthetic division.
Okay. I'm just trying to get my textbook open.
Okay, I will choose one before you will choose. So let's say number 14 on page 392. 14 has x to the fourth plus 2x cubed minus 4x squared minus 5x minus 6. Can you see here, everyone? And it's divided by x squared plus x minus 2. Now, if you ask, where will I use the division of polynomials in this class? Or any other, depending on what you're doing next. But this is used only for section 3.5. I need to explain this for section 3.5. Okay, then. Two questions I ask myself right now. Number one, a descending order. Both polynomials have to be arranged in descending order. Yes, the polynomial has degree 4. It has degree 4, it has degree 3, degree 2, degree 1, degree 0. Polynomial in the denominator has degree 2, degree 1, degree 0. Yes. Otherwise, I have to rearrange them. My second question is, only for the numerator, are there missing terms from the numerator? Only numerator. And you can say, how will I know? What are you talking about? Here's what I'm talking about. Because the degree of this polynomial is 4, it has to have, if it's a full polynomial, it doesn't have to, but if it's a full polynomial, it has to have degree 4, degree 3, degree 2, degree 1, degree 0. If, where is my prop? If it happens that it does not have the term with degree 3, in the long division, we will leave a space, like we did last time. But it happens that in this case, all terms are there. Fine. So then I don't need to leave any space. And I can start the long division. So x to the fourth plus 2x cubed minus 4x squared minus 5x minus 6. And this is x squared plus x and minus 2. We start by asking ourselves the first term and the first term, as if nothing else matters. X squared times what is x to the fourth? And my answer is, of course, x squared. X squared has to be distributed to these three terms. And then before I write under it each like term, I have to change the sign. If this product is positive, I will write here negative. If this product is negative, I will write here positive. Exactly the opposite. X squared times x squared is x to the fourth, but I have to subtract. X squared times x is x cubed, but I have to subtract and I have to write under like terms. X squared times negative 2 is negative 2x squared. I have to write positive 2x squared, and I have to write under like terms. Now I perform the operations I see. 2 minus 1 Negative 4 plus 2. Bring down the next in line. Next step. I never lie here at the top. So quote unquote, you know what I mean. What times x squared is x to the third? And I have to write the symbol. If I don't write the symbol, I can continue. So the answer is plus x. Notice that at the top, degrees have to decrease. If I have here x squared, I cannot have here x cubed. If I start with x squared, the next one has degree 1, and the last one has to have degree 0. So now I distribute x to these three terms. I change the sign and write under the like term, corresponding like term. X times x squared is positive x cubed. I have to change the sign. X times x is x squared. It becomes negative x squared. I change the sign because it was positive, and I have to write it under like term. X times negative 2 is negative 2x. I change, it's positive 2x, and I write it under like term. These two go away. Negative 2 minus 1 is negative 3x squared. Negative 5 plus 2, is negative 3x. And now I bring down the next in line. Sorry about that. My whiteout is new. I didn't realize it was full like that. Good. Final question. How do I know it's final? Because degree 2. I will not have anything else. This is the last step. X squared times what is negative 3x squared? So the answer is negative 3. Negative 3 times x squared is indeed negative 3x squared, but I have to write the opposite. Negative 3 times 1 will be negative 3x. Negative 3 times x is negative 3x. Change the sign. And negative 3 times negative 2 is positive 6. Change the sign. And box in the negative 12. Of course, if you have any doubts, it will take a blink to check. So here's how we write the answer. So I'm going to copy the problem again. Let me push this further back. I have some more room here. All my devices are like almost a mile away from me. I'm kidding. Okay, so x to the fourth plus 2x cubed minus 4x squared minus 5x minus 6. Everything we divided it by x squared plus x minus 2. I have to write the quotient. All this is the quotient up there. It's x squared plus x minus 3. Now I have to copy the sign in front of the fraction line because the remainder is negative. Sorry about that. And I have to divide by x squared plus x minus 2. Hello? Yeah, of course, I knew it's robocall. But I keep it on for my students in case there is a problem. Okay, so now let's say you want to check. You don't trust this. So remember when we divide 10 by 3, we get 3 integers plus 1 over 3. 3 times 3 is 9 plus 1 is 10. That's exactly what I'm going to do. I'm going to multiply this by this and subtract 12. And if I don't get all this polynomial at the top, something is wrong. You don't have to check. I just want to convince you. So I have x squared plus x minus 3 multiplied by x squared plus x minus 2 and minus 12. If I perform these operations, this times this minus 12, 3 times 3 plus 1, and I do not get the top, I'll say, oops, I have to go back to the drawing board. Something is terribly wrong. Okay, let's give it a shot. X to the fourth, x to the third, negative 3x squared plus x cubed plus x squared minus 3x minus 2x squared minus 2x plus 6 and minus 12. So let's see what we get. The x to the fourth, oh, that's not a good color. The x to the fourth is right there. X cubed and x cubed, yes. The 2x cubed right there. Negative 3x squared minus 2x squared is negative 5x squared plus x squared is, so negative 5 plus 1, yes, indeed, negative 4x squared. Negative 3x with negative 2x, yes. And 6 minus 12, negative 6, yes. Yes, it's the correct answer. Quotient is x squared plus x minus 3. Remainder is 12. And divisor is x squared plus x minus 2. This is the long division. Let me know if you need more long division. If not, we'll move on. And I'll show the synthetic division.
I'm a little confused, but if we don't need it, we can move on.
You are confused on this, or you're confused on the synthetic division, which I haven't presented yet?
Oh, I'm a little confused on this.
Okay, let's choose another. Is there a particular spot where you say, oh, I know I'm getting confused here or there?
I'm just a little confused on like. So I understand like some of the parts. I guess it's hard for me to explain really where I'm confused, but how exactly do you like start this? Like how do you?
So I'm asking myself, x squared multiplied by what is x to the fourth? So the answer must be x squared because I copy the base and add the exponents. So that's how I get the x squared at the top.
Okay, I do understand that. I meant like at the bottom. Like where are you getting all of this stuff right? So
You mean this part?
no. So you put x squared at the top because that's what gives you x to the fourth, right?
Good. So now then x squared times x squared, I have to distribute. X squared times x squared is x to the fourth, and I have to change the sign. Is that changing of the sign not clear?
No, it was the distributing, I guess. So
okay.
You distribute x to the
x squared times x squared is x to the fourth. I subtract. X squared times x is x cubed. I subtract. X squared times negative 2 is negative 2x squared, and I subtract that.
Okay. Yeah.
So then I perform, and then I perform each operation I see, and then I bring down the next in line. And now the next question is x squared times what is x cubed? That's why I get the x.
Okay. It makes sense to me now. I was confused because I didn't realize that you were distributing.
Yes, that's what I showed here. I have to distribute to all and then write these three terms. But exactly under like term. I cannot put 2x squared here or x to the fourth here because I will not be able to add them.
So what if you don't have, like, what if one of the distributed terms doesn't come out as a like term?
It has to. Maybe not under this one, but then I will have to put it under this one.
Okay.
It's a very good question. So let's look at a problem like that. Excellent question. Let's do 28, but not synthetic division, because I haven't explained it yet, but long division. So let's look at 28. Very good question. So we have x to the 7th plus x to the 5th minus 10x to the 3rd plus 12 divided by x plus 2. Well, this is a mess. Especially with the long division, it will be a long procedure. But that's okay. Let's do one. What is the degree at the top? First of all, are they in descending order? Yes. Degree 7, degree 5, degree 3, and degree 0. Degree 1, degree 0. They are in descending order. Are there any missing terms? A ton. Degree 6 is missing. Degree 4 is missing. Degree 2 is missing. And degree 1 is missing. I have degree 7, but not 6 in line. I have 5, but I don't have 4 between these two. I have 3, but I don't have degree 2, I don't have degree 1, and I have directly degree 0. So, x to the 7th, space for degree 6, plus x to the 5th, space for degree 4 that is missing, minus 10x to the 3rd, then a space for degree 2, space for degree 1, and plus 12 at the very end. These spaces may not be necessary, but I have to start by making sure that they are there. If I don't use them, so be it. I don't have to use them, I don't use them. But if they're not there, I will mess it up if I need them. Okay, so I'm dividing by x plus 2. So the first step, again, is x times what is x to the 7th. So the answer is x to the 6th. That's not a good color. X to the 6th. I have to distribute, and I have x to the 6th times x, which is x to the 7th, and that is a like term. But x to the 6th times 2 is 2x to the 6th. I don't have x to the 6th here, so it's this spot as negative 2x to the 6th. Because I cannot put it under any other. Okay, I perform the operations I see, and I bring down the next in line. My next question is, same thing, x times what is negative 2x to the 6th, and the answer has to be negative 2x to the 5th. Negative 2x to the 5th times x is negative 2x to the 6th, but I have to change the sign. Negative 2x to the 5th times 2 is negative 4x to the 5th, but I have to change the sign. And I write it below like terms. They're right there. Perform the operations I see, and now I have 5x to the 5th. I don't have anything to bring down yet. The next term is not there. Okay, I may choose to write this one or not. So let's leave it alone for a moment, and let's continue. X times what is 5x to the 5th, and of course that will be 4x to the 5th. 4x to the 5th times x is 4x to the 4x to the 4th times x is 5x to the 4th times x is 5x to the 5th. Subtract. But now look what happens. 5 times 2 is 10x to the 4th. I don't have where to put it, so I'm going to put it right under here. So it's going to be negative 10x to the 4th. Because I write so big, this should be a little bit to the right. I'm not going to combine them anyway. So 5 times x, 5x to the 4th times x is minus 5x to the 5th. 5 times 2 is 10x to the 4th. I have to subtract. Gone. Negative 10x to the 4th. And now I can bring down the next in line. I'm skewed, as you see here. I'm sorry about that. And of course, I need to go to the next page, which is page 3, by the way. Okay. So x times what is negative 10x to the 4th? That will be negative 10x to the 3rd. Negative 10x to the 3rd. Negative 10x to the 3rd times x is negative 10x to the 4th. Positive 10x to the 4th. Negative 10x to the 3rd times 2 is negative 20x to the 3rd. Positive 20x to the 3rd. These two, sorry about that. As I said, it was going to be a mess. It's a long problem. Combine like terms, 20 minus 10 is 10x to the 3rd. I don't have anything to bring down. I'm missing degree 2. I'm missing degree 1. So x times what is 10x to the 3rd? It's going to be positive 10x squared. 10x squared times x is 10x cubed. I subtract. 10x squared times 2 will be 20x squared. I subtract. I will have to write on the table now. Negative 20x squared. Okay, I don't have anything to bring down because the term with x squared and the term with x are gone, are not there. Okay, so now x times what is negative 20x squared minus 20x. negative 20x times x is positive, negative 20x squared, so positive 20x squared. Negative 20x times 2, you're not going to have to do this, I promise you. So, but I have to finish it now since I started. So negative 40x, so positive 40x. So I only have 40x, and now finally I can bring down the 12. Final question, positive 40, positive negative 40x, and this is positive 80, negative 80. So this is what, negative 68. And we'll check on this one just because I did it kind of on 3 pages. It appeared to be. Okay, so let me write the final answer. So x to the 7th plus x to the 5th minus 10x to the 3rd and plus 12. Is this better, Samantha? Does it make more sense? I know it was a messy problem, as I promised.
Yeah, it does actually make a lot more sense.
Okay, so the answer is x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus. It takes me a page to write the answer. So I'm exaggerating. And then minus 68 over x plus 2. And I'm not going to check